Good afternoon, this is Miss Young, and today I wanted to look through one of the previous questions that I did, and you can see a link to that up in the top here. This is a question, this is question 1 from paper 42 of June 2022, and this was the question on the stack, question 1 on pushing and popping a standard stack algorithm, and in this case they set the stack pointer to be 0, and in that video I explained that a stack pointer of 0 meant that it was empty. In fact, I said that the better name for stack pointer would be free pointer, because there are 0 values in the stack, and then when we add an item to the stack we increment the stack pointer, which will make the stack pointer point not to the top of the stack, but to the value of which the next item to the stack would be added. So if we want to know if it was full, then we would say it would be 10, because we have items 0 to 9, and so this would be 10 here. And I also talked about how we could make this more efficient by doing this the other way round. Sometimes they like to try and switch things up, and sometimes they may ask you to say the stack pointer starts at -1. So I wanted to go through the changes that you would need to make if they decided that the stack pointer was -1. So nothing changes in this procedure here, but in this procedure, because we're starting at -1, then a stack full will be the maximum items -1, which would be 9. But in this case, the item is going to be at stack pointer +1. So what we can do in this case is that we can take this and we can add 1 to the stack pointer first, and then, so if the stack pointer is 0, it becomes 1, and we enter the data at, if the stack pointer is -1 and we add 1, then stack pointer becomes 0, which is exactly where we want to enter that data. So essentially all we do is we swap these two around, and that should work. With pop, again, well, we know our empty status is -1, so we would need to change this to be -1. Now, of course, I did this a slightly more efficient way, but how we kept it the original way, which was this. So in the original way, so again, what we want to do is we can say return value is equal to the stack data, stack data at stack pointer. Then we can decrement stack pointer, and then we can return the return value. So before we had return value is stack data -1, and then we did that -1. Well, now if you had it that way around, so if originally your code looked like this, then you would simply get rid of the -1 here, and that would stay the same. So let's see if that works. I'm just going to print these out again, because we know that it should pop first 20 and then 19 if you look at that other video. So I'm going to run this here, and we have 11, 12, 13, 14, 15, 17, 18, 19, 20. We know 21 should not be added. So again, we can look here, 21 was not added. Now we'll see the stack pointer is at 9, which is correct, because that is the pointer to the actual stack pointer here, 20. Then when we popped, we can see that we popped 20 and 19. And now we can see the stack pointer is at 7, which is 18. And then if we wanted to add a value, a 19 again, then we can, so if we added 19 back, we go push, then the stack pointer would go to 8, and we would put it in at address or index 8, which would be correct. So that was just a quick video to show you how you would change the algorithm if this was at asking you to initialize the stack pointer to be -1 instead of 0. So essentially most of the time it's switching these around, and that should do the trick. The difference then of course is that would be -1 for empty and 9 for full. I've been Miss Young. I hope that's been helpful. Thank you.